Have you ever asked yourself why, in the name of the Lord, you need a Kubernetes cluster running 12 instances of your application just to handle a minimal amount of workload, while your database can handle the same amount of workload with just one instance? I know the answer, and it's ruthless simple. The guy that programmed the database knows better than you. But today I'm going to review the dirty trick behind this so-called magic. So let's start asking for my dear friend ChatGPT, that now is an expert in database, how can Postgres, for example, handle so much workload? And this is what he has to tell me. Postgres handles high workloads efficiently through the use of connection pooling. A connection pool manages a set of reusable database connections, avoiding the costly process of opening and closing new connections every request. Instead, it keeps a limited number of connections open and distributes them as needed among requests, reducing the overhead and optimizing memory and CPU usage. This approach allows Postgres to manage a high volume of simultaneous connections while maintaining system stability, supporting better scalability and performance in high demand environments. Now back to my terminal. Don't dare you tell me that you can't see the similarity between these two solutions. The Postgres connection pooling and your Kubernetes keep running 12 instances of your application. You also keep 12 instances running to avoid the cost of start a new instance every time you need one. And of course, you also do this because of the redundancy, but the scalability is the issue that we are addressing right now. The problem is that keep a container running, start a new container, and even stop a container are high cost operations for operational system. But what if I tell you that you can achieve the same result with a much cheaper solution, a much simpler solution that is more in your control than a solution in Kubernetes will ever be? Let me show you this little simple project in Elixir that has just 3587 lines of code, and 2 of those files are configuration files. Now let's start the application so you can see with your own eyes what I'm telling you. I can start my Elixir project with an interactive prompt with this simple command and start an observer that enables us to see the structure of our solution. The observer tool is a built-in, it comes with Elixir. And here I can see the structure of my application. Have you ever dreamed about something so perfect? So what I have here, I have my application and 4 instances of my service. I also have a puller controller. When a request arrives, my controller will check out an instance of my service to handle the request. After this process is completed, the instance will be inserted in the pool again. This ensures an efficient load balance. I can easily monitor every aspect of my service by clicking here and checking every information, every message that arrives to my service, and verifying the state of my service. Now let me show you the minimal amount of configuration that I had to do to achieve these results. This is all the configuration that I needed to create a pool of services. The name, the module that will handle the requests, the size of the pool, and the max overflow. If you're a beginner or if you don't have much experience with distributed systems, you are probably wondering why go through the trouble of creating my own pool of services if I can use a framework to handle the communication for me, a framework like Phoenix, for example. And the answer is latency. If you are working in a project that is real-time, or you want to work in a project that is real-time, you should consider this. Here we are talking about a binary communication similar to gRPC, but much better, because we are talking about a communication that happens through the Elixir virtual machine. There is no way to be better than this. By doing this, we will eliminate all the overhead of communicating with a REST API, including all the process of connection, the serialization and deserialization of JSON, and you have much more control of your service. And now, if you are a good developer, and I know that you are because you still watching this video, you are probably asking yourself, what happens if one of these instances crash? How can I increase my pool? And it is possible to have more than one pool by application. So if you are interested in seeing me answer these questions, please give it a like, subscribe to the channel, share the content, and thank you for watching. See you in the next one.